8. Now, let's start off with obviously numbers 9 through 24. The directions say to expand the expression. Now, in my class, when I ask you to expand a logarithmic expression, I expect you to do that as far as you can, okay? So here we go. The key, in my opinion, to expanding a logarithm is to look at the argument and see if you have any multiplication or division. Or sometimes you could also look for exponents, okay? In fact, I'm not sure why I said sometimes. Those are the three things you want to look for. Now, I have some multiplication, 3 times x. Now listen to me carefully. How many things am I multiplying? 2, a 3 and an x. So if I'm multiplying 2 things, for lack of a better word, if I'm multiplying 2 things, then I want to write 2 logarithms. So there's one and there's the other. Now, remember, if you have an argument that's being multiplied, you can split it up. Put part of your argument here, the other part of your argument here, and then add the 2 logarithms. It's that simple. If the 3 and the x would have been dividing, if there was a fraction bar here, it was 3 over x, 3 divided by x, then you would put a minus sign here. Okay? Remember, when 2 logarithms are being added, you can write them as 1 log if you multiply the 2 arguments, and the same is true. Going backward, if you have a logarithm with an argument that's a product, then you can split it up into 2 logarithms that are being added. Now, we're done. That's it. If there would have been a 2, so there was a 4 right here, then you would not be finished until you pick that 4 up and put it right over here at the end. But we don't have to worry about that. I don't see any exponents at all, so we are totally good. There's your answer. And by the way, the answers are on the side of my teacher's edition book, and every answer I write down, I am checking it to make sure we're doing these correctly. Number 10. Okay, exact same thing. We're looking for multiplication, division, or exponents in the argument. Well, I have some multiplication. How many things am I multiplying? 2, a 16, and an x. So I want to write 2 logarithms. Logarithm base 8. Logarithm base 8. Now, the first part of my argument is 16. The second part of my argument is x. And since the 16 and the x are multiplying, I'll put a plus sign here. If they would have been dividing, I would put a minus sign right here. That's it. We're done. There's nothing else we can do when it comes to expanding that. All right. Let me check the answer key real quick. That is correct. Moving on. Number 11. All right. Now, look at your argument. I have multiplication, and a power. But even though I have a power, students, you understand I'm still just multiplying 2 things. I'm multiplying a 2 and an x cubed, okay? So I'm multiplying 2 things. So I'm going to write 2 logarithms. Now, if you want to write base 10, you can, but you don't have to. Remember, when there's no base written, it's understood to be 10, okay? Now, the first part of my logarithm is 2. Or, sorry, the first part of my argument is 2. And the second part of my argument is x cubed. They're being multiplied, so I'll put a plus sign here, okay? Now I'm almost finished, except when you're expanding, you do want to move your exponents, okay? So we're going to move this 3 to right here, and now we're finished. That's it, guys. I mean, it just doesn't get any simpler than that, okay? Moving on. If you would have left the 3 right here, that would have been incorrect. That is not right. When you're expanding, I want no exponents left, okay? Number 12. Okay, now, I really don't have any multiplication or division. All that I have is this. So I'm simply going to pick up the 3, bring it right here, and I'm finished. There's nothing else I can do. Nothing else I can do. Now, by the way, okay, that's my answer, okay? I'm going to erase this in a second, so write it down if you need to. Some of you might have said this, oh, Mr. Earhart, it's x cubed, so you really have this. X times x times x. Okay, no problem. I have no problem with that. I mean, it's going to be longer doing it this way, but that's fine. How many things am I multiplying? 3. 3 logarithms. X goes here, X goes here, X goes here. They're all multiplying, so you add them. But look, guys, if you have log base 3 of x, log base 3 of x, log base 3 of x all being added together, there's really a 1 here, even though you can't see it. A 1 here and a 1 here. So when you add those logarithms together, you get this, which is the exact same thing I just told you the answer was by simply picking up that 3 and moving it right there. This is the answer. Alright. Number 13. Okay, now I notice my argument is dividing. Everybody see that? Dividing. Okay. How many things am I dividing? 2, a 6, and a 5. So I'm going to write 2 logarithms. My base is 4. And then the top of my fraction would go here. My divisor or denominator goes here. And since they're dividing, I subtract the 2 logarithms. We are done. That's simple. Just that simple. Moving on to number 14. Now, this one here, I really don't care for this one, to be honest with you, but okay, fine. Here's what they wanted you to do. They wanted you to put 3 squared. Okay? Here's the problem I have with this problem, by the way. Look back. I like consistency. And back here on this problem here, they did not have you right. See the 16 right here? They did not have you right. 2 to the 4th power. And then put the 4 over here because 2 to the 4th power is 16. They left it like this. But then over here in this problem, they expect you to kind of read their minds and put 3 squared. Anyways, that's fine. I would not give you one like this on a test or a quiz, but rewrite the 9 so it's 3 squared. And then pick up the 2 and move it right there and you're finished. 2 logarithm base 5 of 3. And that is the answer they have in my answer key. Okay, moving on to number 15. Excuse me. Notice on number 15 we have an argument that's dividing. Now how many things are we dividing? 2. So I'm going to put 2 logarithms. Both of them will have a base 6. Now the 10 would go here. The 3 would go here. Because they're dividing, we'd subtract. And we are done. Nothing more we can do there. Alright, moving on to number 16. Good, now we're getting into some more multiple type of argument problems. We need that. Okay. Notice here in this argument, I have all multiplication. I'm multiplying 3 things. Okay? 3. So, because I'm multiplying 3 things, 1, 2, 3, I'm going to write 3 logarithms, okay? Six would go here, logarithm of 6, logarithm of x, logarithm of y. Because all of these are multiplying, we'll put plus signs in between them. And that's it. There are no exponents to move to the left of the logarithms. That is your answer. Let me check the answer key real quick to make sure I'm not overlooking something. And we are good. Moving on. Number 17 is identical. Only we have 4 parts. So we have 4 things, if you will, being multiplied. So I'm going to write 4 logarithms. I'm not going to put the 10. You can if you want to. It's understood to be there. Logarithm of 7. Logarithm of x cubed. Logarithm of y. Logarithm of z. They're all multiplying, so we'll put positive signs. And it looks like we're done, but don't forget the 3 right here. We've got to take this 3 and move it to right here. Make it just a little bit bigger so it fits. And there we go. That's it. We're done. Guys, these are really not difficult, okay? Let me take a look at the answer key to make sure we're doing these correctly. And everything looks good. Yep, moving on to number 18. Okay, kind of redundant. We have an argument that has 2 things being multiplied. 2, alright? So I'm going to write 2 logarithms. Base 6. 6 right here like this. 6 squared plus 2 logarithm base 6 of x, and then bring the 2 over here. I am not going to require that. If you do that, fine, on a test or a quiz. If you don't, that's fine also. This is sufficient for me. This is also acceptable too. Either one of those two answers would be fine. Number 19. Okay, now look at our argument. I'm looking for multiplication, division, or exponents. Well, I have multiplication. I have two things being multiplied, x to the 1/2, y to the 3rd. So if I have two things being multiplied, I'm going to write two logarithms with base 2. Alright, here I'm going to have x to the 1/2 power, and over here I'll have y to the 3rd power. Okay, and of course a positive sign here. Why a positive sign? Because they're multiplying. If they would have been dividing, I'd put a negative sign here. Now bring this 1/2 to the left. I'll just cross it off, be a little sloppy here. Put a 1/2 here, and then get a little space here. Cross off this 3 right here, and it would go right here. Let me check the answer key to make sure I've not missed anything, and that is correct. We have taken this and expanded it into two logarithms. Number 21. Same thing again. Our argument consists of multiplication. Okay, multiplication. So I'm multiplying two things. 12 to the 2/3 and x to the 7th. So here we go. I'm going to write two logarithms with base 3. My 12 to the 2/3 would go here. My x to the 7th would go here. Because they're multiplying, we'll put a plus sign here. And here we go. This 2/3, of course, would be moved out here. And this 7 right here would be moved to the left of the logarithm. Right here. And that is your answer. Let me check it real quick. Yes, that is correct. So not too difficult, guys. Number 21. Alright, now, when you look at that, you're going to say to yourself, there's really not anything I can do, but that's not correct. You have the logarithm of x to the 1/2 power. Remember, there's a 2 here, square root, and there's a 1 here. So whenever they give it to you like a radical like this, you will want to write it in a rational exponential form first like this, and now simply bring the 1/2 out front, and we're finished. Okay. 1/2 logarithm of x. 1/2 logarithm of x. Okay. Let me check the answer key, and yes, that is correct. 22 is going to be just about identical, except because we have a cubed root, we're going to put x to the 1/3. Because I have a 3 here, I have a 1 here. So you put the 1 up top, the 3 in the bottom. The cube root of x is the exact same thing as x to the 1/3 power. Now, pick up your 1/3, of course, and move it to the left, and we are finished. 1/3 times the logarithm of x with base 2, or logarithm base 2 of x. Let me check the answer key, and we are good. Moving on to number 23. Alright, now, pretty much like the last two guys, I have logarithm base 10. You don't have to write the 10 if you don't want to. X, the cube root of x squared would mean x to the 2/3 power, 2/3 power. This 2, the exponent goes up top, the index 3 goes in the bottom. And now you simply take that and put it to the left. 2/3 logarithm of x. 2/3 logarithm of x. Of course, there's no base. It's understood to be 10. We call that a what? Common logarithm. Alright, number 24. Now, let's be really, really careful here, okay? There's quite a few ways to do this, students. I'm gonna do this different ways. Okay, first of all, this entire expression under the radical is one term. It has a power of 1, and your index is 2. So you could do this if you wanted to. Logarithm base 2 for with that? I'm going to do this 2 or 3 different ways, okay? Now next you can do this. You have 1/2 times this logarithm. So how about if I put 1/2 and then put a parentheses, and let's split this logarithm up. Now you have to put the parentheses because this 1/2 is being multiplied times this entire logarithm. If you're going to split this logarithm up into 2 logarithms, this 1/2 still goes to the entire expression. So here I have multiplication 4 times x. That's 2 things being multiplied. So I'm going to write 2 logarithms. Okay, 4 would go here, x would go here, and a plus sign. Okay, now don't forget this 1/2 can get multiplied through, so now we have 1/2 logarithm base 2 of 4 plus logarithm base 2 of x. Okay, now I have a 4 right here, so I can definitely write that as 2 squared. Okay, 2 squared. So this 4 is really 2 squared. Okay, and we learned when this number here matches this number here, the entire logarithm just cancels out and you're left with whatever the exponent is. So log base 2 of 2 squared, the answer is just 2. Let me go over that again. You've got to know your properties, guys. 4 right here can be rewritten as 2 squared. 2 squared. And remember, whenever this number matches this number, you can cross all of this off and just keep the exponent. So now what I have is 1/2 times 2 plus logarithm base 2 of x. And 1/2 times 2 is 1. 1 plus logarithm base 2 of x. And that is the answer they have in the book. That's one way to do it, okay? Here's another way to do it. Back to the beginning. We have 4x to the 1/2 power. Got it? So we write it like 1/2. Now, there's a power here and a power here, correct? Take your 1/2 and multiply it through, and you would have the logarithm base 2 of 4 to the 1/2 power, x to the 1/2 power, okay? Now, 4 to the 1/2 power really means what? The square root of 4. You guys know that. 4 to the 1/2 power, your 2 goes here, your 1 goes here. So 4 to the 1/2 power is really 2, the square root of 4, which is 2. So now I have logarithm base 2 of 2, x to the 1/2. Now we're cruising, and now I have 2 things being multiplied. So I'm going to write 2 logarithms. But a base 2 and a base 2, your 2 would go here, your x to the 1/2 would go here. And they're multiplying, so I'll put a plus sign. Now, for this logarithm here, we know that whenever a base matches a base, the entire expression equals the exponent, and the exponent is 1. So the base matches the base, these 2 numbers match, everything's gone except for this. So 1 plus, bring the 1/2 out front, or to the left, log base 2 of x, exact same answer I got a second ago. And still yet, there's another way you could do this. You could also say, we have the square root of 4x. Well, I know the square root of 4 is 2, so logarithm base 2, square root of 4 is 2, so now I have 2 times the square root of x. And of course, the square root of x, well, we're multiplying 2 things here, so we're going to write 2 logarithms. And all of these methods are fine. Put the 2 here, put the square root of x here, and they're multiplying, so put a plus sign. Now, x to the square root of x right here is the same thing as x to the 1/2. And then we're back to where we were in the last problem. These 2 numbers match, so your answer is the exponent, so everything's gone except for this number. And over here we put the 1/2 to the left. Logarithm base 2 of x, exact same answer. So any of those ways will work, okay? Alright. The last 4 problems are really cool problems. We're going to be using the logarithm of 3, the logarithm of 3, and the logarithm of 12 to solve these problems. This should be really, really interesting, okay? So here we go. Okay, students, now please, these next four problems are pretty challenging. Please listen to me. Do I know the logarithm of 4? Yes, I know you can type it into your calculator. We're going to pretend you're not allowed to use your calculators, okay? And on a test or a quiz, I will say you're not allowed to use your calculators. Now, okay, we're trying to find the logarithm of 4. Well, I know what the logarithm of, notice all the bases are the same. That's really important that you see that. Okay, that's good. That's necessary. Now, we know the logarithm of 3. We know the logarithm of 12. We do not know the logarithm of 4. So how can I change this 4 over to a 12 and a 3? Well, I've got an idea. How about this? I'm not going to put the 10 here. What's 12 divided by 3? 4. Is it not? Sure it is. So instead of putting 4, put 12 divided by 3. Why, Mr. Earhart? Why those two numbers? Why not put 16 divided by 4 or 20 divided by 5? I'll tell you why. I chose these two numbers because I have a 12 here and I have a 3 here. So I wanted to use 12s and 3s because here's why. Watch what happens now. I have the logarithm of this fraction. So I have two things being divided. Two things. So write two logarithms. Put the 12 here. Put the 3 here. They're dividing, so put a subtraction sign. Now, see this logarithm of 12, what does that equal? Well, I have no idea, Mr. Hart. Yeah, you do. Look up here. Logarithm of 12 equals 1.079. Minus, what's the logarithm of 3 equal? 0.477. Subtract those two numbers with a calculator and you will get that right there. And by the way, if you want to check the work, type this into your calculator and you will get the exact same decimal. Let's try number 6. Okay, we have a 1/4. Got it? And all that we have to deal with here is a 3 and a 12. Well, guys, I've got an idea. Instead of using 12 over 3, let's use 3 over 12. Because 3 over 12 equals what? 1/4. So I'm going to rewrite my logarithm like this. Instead of 1/4, I'm going to put 3/12. Now again, why did I use those two numbers? Well, two reasons. First of all, this expression has to equal this expression. Look at the last problem. This expression here, 12 divided by 3, equal to this number here. It has to. You can't substitute this in for 4 if it doesn't equal 4. So first of all, I use this because it equaled this. Secondly, I use 3 and 12 because I have a 3 and a 12 up here. Now, I'm dividing two things in my argument, so I'm going to write two logarithms. The 3 will go here. The 12 will go here. They're dividing, so I'll put a subtraction line, subtraction sign. And now, logarithm of 3 equals 0.477 minus logarithm of 12 is 1.079. Subtract those two numbers and you will get negative 0.602. And by the way, if you want to check my work, type this into your calculator and you will get negative 0.602. Number 7. Okay, we have a 36. How can we get a 36 using a 3 and a 12? Well, guys, that's pretty obvious. Come on. 3 times 12. Now I'm multiplying two things, so write two logarithms. 3 goes here. 12 goes here. They're multiplying, so put a plus sign. Logarithm of 3 equals 0.477 plus logarithm of 12 equals 1.079. Add those two numbers together and you will get 1.556. If you want to check my work, type this into the calculator and you will get this right here. Last problem, we're finally done. Here we go. Logarithm of 144. Well, how can I get 144 using 3s and 12s? Well, I can think of one way. Logarithm base 10 of what? 12 squared, right? Or you can do it this way if you want. How about this? Logarithm of 12 times 12. Either way will work, okay? I'm going to work it out both ways. Here, I pick up the 2 and I move it where? Right here. So now I have 2 times the logarithm of 12. Well, the logarithm of 12 is 1.079. So 2 times 1.079 will give you 2.158. If you want to check my work, type this into your calculator. and you'll get this right here. Now, also over here I have two numbers being multiplied, 12 and 12. So write how many logarithms? 2, correct? Put a 12 here, put a 12 here. They're multiplying, so put a plus sign. Now, the logarithm of 12 is 1.079 plus the logarithm of 12 is 1.079. So whether you're taking 1.079 times 2 or whether you're adding these two together, either way you'll get 2.158. Okay, guys, these logarithms can be really cool to work with. They really can be. I hope this homework help video was a help to you. If you have any questions, don't hesitate to call or email.